First question. Yeah, boys, we have to
Sorry.
do more with you.
Hello everyone, I'm Drew, and my part is sequence diagram. And this week I did two processes for sequence diagram, and the first one is registration. And the voter, if the voter is the first time to the official office, they need to register their ID. So. The officer needs to check the voter's ID, and on the website, the voter fill his ID in the on the website, and the web page could call the voter project, and then this object could has a method to check the ID. If this voter have validation, then the object could return true. If not, they could return the error message. So return true. If it is true, so the voter object could be created, and the voter have validated to get his smart card. And second one is the smart card checking. If the voter insert his smart card into the machine, and the machine could check if he had voting or not. If he had already voting, then they could not do that again. And if he didn't voting, and they can go on to do the next. So this is my part.
So thank you, Drew, for the sequence diagram, for describing the sequence diagram. So we'll now move on to the deployment diagram. So this deployment diagram is just a basic prototype for now. So once we have a complete class and sequence diagram, I'll improve upon this. So basically we have three nodes over here. One is the admin node, one is the voting system node, which is basically the centralized system, and one is the voter ID card node, which is the voter ID card that every voter is going to get. So each of them, the voting system has a broad artifact right now, which will be expanded upon in further sprints called voting functionality. So this this is communicated with the ballot definition of the voter ID card, so that the voting functionality is changed according to the different customized ballot specification that the particular voter has. And also there is a voter reprogram functionality in which we can reset the voter ID card every time there is a new candidate who comes to vote. So then after that, below that you have admin who is responsible for starting out the election and for controlling the voter cards and reprogramming them. So that can only be done by the admin. So now we have these three nodes have two associations with each other. And then you have dependencies which are mainly on centralized dependencies on the voting system. So admin configures the voter ID card, and voter ID card is applied to the voting system. So these are the associations. So yeah, so that is a basic deployment diagram, and there will be more detail which will be added to it in future.
Yeah, thank you, Anurag, for the detailed description of the deployment diagram. So I am here to deal with the security plan. In order to have a proper security plan, you need to identify the threats and the risks involved in the case. So after you got a clear idea about the executive summary on how the case is going to be proceeding, so I'll be treating with the threats which are involved in this. So after you get all the vote, after all the votes are being polled, so you need to send this voting booths to the voting booth securely without being corrupted or losing information. So this might be a threat to the case and misrepresenting the identification information to cast vote instead of the other person. So it is also unethical. So it's also considered as a threat to the case, and duplicating authorization cards and finalizing cards to access the system without being authorized to use so. So It is also another threat for the system. It's because it is not authorized to do so. And intruders accessing the voting database might also be a very big threat. So they can manipulate the votes in their favor. And also replicating the smart card for multiple voting purpose. It's because you could only vote once. Replicating the smart card for voting more than once is also is not part of system. So it may be a threat. So you need to address these threats and also prepare a precautionary way in order to address them. So after we talked about the risks involved, we need to identify the actors and entities who are being affected by these risks. So with the ballot definition being sent to the voting booth securely, if it isn't being sent, the systems engineer would be an entity which would be affecting, and also the opposition political party might also get affected. So this doesn't work properly, and it might be a big problem for the genuine voters. So these effects of risk are manipulating of voters' preference. They could manipulate the voters' preference and change them in favor of them. And for this, the precaution which we came up to is usage of secured firewall in order to send them properly to the ballot booths. So the second risk involved is misrepresenting the identification information to cast vote instead of the other person. So this could be leading eventually to the loss of votes of genuine voters. They would have a genuine loss of voters. So the entity which would be affecting is election authority, and the team which and in our system, in our case, the thing which we need to look on is acceptance criteria team of the system. So we need to make sure that none of the other identification which are being mentioned should not be able to identify the voter and give him a right to vote. So the basic precautionary as of we came to know was to find a we need to find the duplicate identification and improve the identification system even more better by using the face recognition technique and all. So the third thing is duplicating authorization cards and finalizing cards. So in order to get rid of this, the systems architect and IT engineer need to work on it more. So it can also prevent the voters of other contestants from casting their vote. Once they get to know the definition, ballot definition, once they get to identify the voters by the ballot definition, they might prevent the voters. They might prevent those voters from voting to their other contestants. So it might be a huge loss and data loss. And the precautions we have come up to is authentication of card before usage by the official. So proper official should be used for the card usage, and none of them other people should be using that. So that should be properly authenticated. And also after the voting has been recorded, the intruders may access the voting database, and this would finally completely crash the system. So they can perform all the malicious activity which they could do and also manipulate the votes. So the entity or actor affected or involved in this would be database engineer. So he needs to look upon this. And also the precaution which we came upon this was using intrusion detection system. So not letting any of the other people out of the system being able to access the system. It's intrusion detection system. And the last thing is replicating the smart card for multiple voting. Uh, it can be done by replicating the smart card or even hacking the smart card for multiple voting. So acceptance criteria team should even more look into that, so that there would be uh, no misusage of the smart card. And the precautions was changing the smart card and not revealing it to the public until the election gets over, so that there would be no chance of replicating the smart card, and people would be having every right to vote genuinely. So that's from the first sprint of the electronic voting system. Yes, and thank you.